Event functions. A script in Unity is not like the traditional idea of a program where the code runs continuously in a loop until it completes its task. Instead, Unity passes control to a script intermittently by calling certain functions that are declared within it. Once a function has finished executing, control is passed back to Unity. These functions are known as event functions. So let's go here real quick. Order of execution for event functions. So again, running a Unity script executes a number of event functions in a predetermined order. So a script lifecycle overview. So information about the various event functions. So we're gonna have the first scene load, the editor before the first frame update, in between frames, update order, animation update loop, rendering, coroutines, when the object is destroyed, when quitting. And here we have a flowchart. So we have the legend, we have the initialization, editor initialization, we have the physics, input events, game logic, scene rendering, gizmo rendering, GUI rendering, end of frame, pausing, and the commissioning. So let's go back here. Okay, these functions are known as event functions since they are activated by Unity in response to events that occur during gameplay. Unity uses a naming scheme to identify which function to call for a particular event. For example, you will already have seen the update function called before a frame update occurs, and the start function called just before the object's first frame update. Okay, so if we go into the software, and you can pick, okay, I'm gonna go here and just grab whatever, let me see, yeah, the projector or whatever file in C# is gonna prompt us to open Visual Studio Code. And here we see these functions, the void, the start, and here we have the void on collision enter. So but we also have the, let me see, maybe this one, the update, the void up. Okay, this one has the void update function. Okay, so these are the ones that they are mentioning here. Many more events functions are available in Unity. The full list can be found in the script reference page for the MonoBehavior class, along with the details of their usage. The following are some of the most common and important events, so you can check out the MonoBehavior is right here. And one thing, you can switch it up to scripting. Right now we are in the manual, so we are here in the manual, so you can switch it up to scripting. But the MonoBehavior class is the base class from which every Unity script derives by default. When you create a C# script from the Unity's project window, it automatically inherits from the MonoBehavior and provides you with a template script. So you have that, you can check out more about it. Now, regular update events. A game is rather like an animation where the animation frames are generated on the fly. A key concept in gaming programming is that making changes to position, state, and behavior of objects in the game just before each frame is rendered. The update function is the main place for this kind of code in Unity. Update is called before the frame is rendered and also before animations are calculated. So they give us an example here, this piece of code. So we have this function, so we have the void update, or this method. So we have the void update. So inside of the curly braces we have the flow distance, and we are setting it to the speed multiplied by the time, that delta time multiplied by the input that get access, and we're passing horizontal. So we ended up with the semicolon, and then we have the transform that translate, and we pass in the vector 3 that right multiplied by the distance. Now we also have the physics engine. The physics engine also updates and discrete time steps in a similar way to the frame rendering. A separate event function called fix update is called just before each physics update. Since physics updates and frames updates do not occur with the same frequency, you will get more accurate results from physics code if you place it in the fix update function rather than update. So now we have the, and we can go to, okay, we could go to Visual Studio Code and just type it in, but well, here we have just this void fix update function. Okay, so inside of the curly braces we have the vector 3 force, and we are setting it to the transform that forward multiplied by the drive force multiplied by the input that get access, and we're passing the vertical semicolon at the end, and then we have the rigid body that add force, and we're passing the force. It is also useful sometimes to be able to make additional changes at a point after the update and fix update functions have been called for all objects in the scene and after all animations have been calculated. An example is where a camera should remain trained on a target object. The adjustment to the camera's orientation must be made after the target object has moved. Another example is where the script code should override the effect of an animation, say to make the character's head look towards a target object in the scene. Now we have the late update function can be used for these kinds of situations. So we have the void late update, and we have the camera that made that transform, that look at, and then target that transform. Initialization events. It is often useful to be able to call initialization code in advance of any updates that occur during gameplay. The start function. Okay, so we already see here. Let me see. Let's close this one. And let's go into projector. I think this one, yeah, we have here this function. We have the void star. So let's close this with the let's close that. Okay, the start function is called before the first frame or physics update on an object. The awake function is called for each object in the scene at the time when the scene loads. Note that although the various objects start and awake functions are called in arbitrary order, all the awakes will have finished before the first start is called. This means that code in the start function can make use of other initializations previously carried out in the awake phase. Now we're gonna see the GUI events. Unity has a system for rendering GUI controls over the main action in the scene and responding to clicks on these controls. This code is handled somewhat differently from the normal frame update, and so it should be placed in the onGUI function, which will be called periodically. So we have the void onGUI, and then we have the GUI.label, and we're passing the label React, and then inside double quotes game over. Okay, you can also detect mouse events that occur over a game object as it appears in the scene. This can be used for targeting weapons or displaying information about the character currently under the mouse pointer. A set of on mouse, okay, XXX event functions. So we have the on mouse over, we have the on mouse down, is available to allow a script to react to user actions with the mouse. For example, if the mouse button is pressed while the pointer is over a particular object, then an on mouse down function in that object script will be called if that exists. Now, just to finish this, we have the physics events. The physics engine will report collisions against an object by calling event functions on that object script. The onCollision enter, onCollision stay, and onCollision exit functions will be called as contact is made, held and broken. The corresponding onTrigger enter, onTrigger stay, and onTrigger exit functions will be called when the object collider is configured as a trigger, i.e. a collider that simply detects when something enters it rather than reacting physically. These functions may call several times in succession if more than one contact is detected during the physics update, and so a parameter is passed to the function given details of the collision, position, identity of the oncoming object, etc. And the example that they give us is void onCollision enter, and we are passing other object calling collision, and inside of the curly braces we have the if statement. So if other object that tag is equal to the arrow, so to this double quotes arrow, so this string, then we're gonna apply damage and we're gonna pass the number 10. So this is all that we have for the events functions. And here in this particular, okay, so we are inside of the scripts concept, inside of scripting. This is the order of execution for events functions. So this is the diagram that they're providing us. Okay,